video, I'm going to demonstrate transforming a figure using the coordinate plane as my tool. So in this problem, it says transform triangle ABC according to each rule. Name the transformation the rule represents. So the first thing I need to do is find the coordinates of my vertices. A is at -5, 3. B is at 2, 6, and C is at 5, 2. The next thing is to take my vertices of my preimage, my original, and apply the rule that they want me to use to transform the figures. So in number 1 it says -x, -y is my rule. Now what that means is basically it's -1 times the x coordinate and -1 times the y coordinate. And when you do that, basically all you're doing is changing the sign of the coordinates. So I'm going to list my names of my vertices of my image, which is what you get after you do the transformation. And then I'm going to use prime symbols to show that it's the vertices of my transformed image. And then I'm going to apply the rules. So the coordinates of A are -5, 3. And if I multiply each of those by -1, which is what my rule told me to do, I will get 5, -3. So it's basically just changing the sign. So B would become -2, -6, and C would become -5, -2. Alright, then what I do from there is I plot my new points. So A prime would be 5, -3. B prime would be -2. I'm going to have to estimate because I've run out of coordinate plane here. And C prime would be -5, -2. And then I connect those vertices, sketching it out. And what I see is initially it looks like the transformation that took place here was a flip. But if it was a flip, then the C, when reflected, would have mapped down to this position. And what I see here is A prime, not C prime. So I have to go back to the drawing board. This is not a reflection. But what it is actually a rotation. So if I take A and I rotate it, it will map onto where A prime is. So the idea is that this is a rotation. And it's not enough just to identify the type of transformation. We need to be more specific. So it's a rotation, but when I rotate, it's by a degree measure. So the idea is A turned completely opposite of what it was. So -5, 3 to 5, -3. And that would be a complete opposite turn, which would be 180 degrees. So what I can gather from this is that when I see this rule, -x, -y, it's going to give me a rotation of 180 degrees. Now, number 2, this time I'm going to use double primes because I'm going to use the same coordinate plane. If I was using a new one, I wouldn't have to do that. And this time it's x -2, y +3. So that means I take the x coordinate, I subtract 2, I take the y coordinate and add 3. So for A, -5 - 2 is -7. And 3 plus 3 would be 6. So my A double prime would be at -7, 6. And go down the line, apply the rules. So x -2, 2 - 2 is 0. And y +3, 6 + 3 would be 9. And then C double prime, 5 - 2 is 3. And 2 + 3 is 5. So now plot those points. -7, 6, -7, 6. That's a double prime. 0, 9. So 0, 6, 7, 8, 9. Again, I'm estimating because I've run out of coordinate plane. And that's B double prime. And then C double prime would be at 3, 5. And so when I look at it, it looks like I slid my triangle this time. And a slide is a translation. And with these, again, we want to be more specific than just saying the transformation. So it is a translation, but how far did I translate it? Well, if I start at A and I move to A double prime, I go up 3 and to the left 2, which makes sense because it's y plus 3, which is the up 3, and x minus 2, which is the left 2. So I could just look at the rule and know that it's a translation up 3 units and to the left 2 units. So that would be my complete response. Translation up 3 units and left 2 units. Alright, last one. 1/4 x, 1/4 y. So when you have a number out front here, that means multiply times the x variable, multiply times the y variable. And this time it's a fraction, 1/4 times x. And if you remember your fraction rules, 1/4 times x is the same thing as dividing by 4. Because the numerator's 1, so 1 times x would just be x, over 4 would be dividing by 4. And I'm going to use triple primes this time because we're using the same graph. But, you know, if you're using a new graph, you don't do triple primes, you just do a prime. Alright, and I'm going to divide each of the coordinates by 4 according to this rule, the x and the y. So -5 divided by 4 is -1.25, or you put in your calculator if you can't do these in your head. 3 divided by 4 is 3/4, which is 0.75. B triple prime, B's coordinates are 2, 6. 2 divided by 4 is 1/2, which is 0.5. 6 divided by 4 reduces to 3/2, which is 1.5. C triple prime, divide these by 4. We know 5 divided by 4 is 1.25 because we did it up here. And 2 divided by 4 is 0.5. Now we're going to have to estimate these because these are decimals. 0.25 is a fourth. So we just go a fourth of the distance. 0.75 is 3/4, so I go 3/4 of the distance, and so on. So A triple prime, -1.25 I would estimate to be there, and then up 0.75, which is between 1/2 and 1. So that would be A triple prime. B triple prime over 1/2 up 1.5. And C triple prime 1.25 and then down halfway. So when I sketch this out, it definitely got smaller, which is a dilation. And again, we want to be more specific. So when we dilate something, it's by a scale factor. And the nice thing about these rules is the scale factor is right there for you because you multiplied everything by 1/4, so you scaled it down by a fourth. So it's a dilation by a scale of 1/4. And so that's how you would transform a figure using the coordinate plane as your tool. And each of these would be rules to help you do those transformations. So in the future, when you see -x, -y, you know it's going to be a rotation of 180. When you see x minus something, that's to the left that many units. X plus something would be to the right that many units. Same thing with y, except up and down. And then when you multiply, it's going to result in a dilation by a scale factor of whatever you're multiplying by. So just keep all this in mind for your quiz, and good luck.